we had an algebraic expression that contained a set of parentheses like this. If we wanted to try to simplify that algebraic expression, we would want to see if there are any like terms we can combine. But unfortunately, the 2x is not a like term with the 3. The 2x is a variable term, the 3 is a constant term, so I can't combine them together. So there's really, in this expression, as it is, there's really no way I can simplify it by getting rid of the parentheses. I'd really like to be able to do that to make my expression less complicated. Parentheses generally make algebraic expressions more complicated. If we can remove them, that generally makes them simpler. Well, that's because I can't simplify it because I can't add those two terms. But what if we just had a strictly numeric situation? What if we had this arithmetic expression? We would be able to do the addition of 5 plus 3, wouldn't we? Because those are like terms, we can add those together. Then we could do the multiplication. That's the way we would do it, following our order of operations. The order of operations says we should do that addition inside the parentheses, then do the multiplication. But watch this. I can go outside of the order of operations if I'm careful when I'm working with multiplication in conjunction with addition or subtraction. If I will do this, if I will distribute the multiplication over both of the terms that are in the parentheses, so 4 times 5 gives me 20, 4 times plus 3 is plus 12. If I will distribute the multiplication times both of those terms first, then add, the result is the same, and it will always be the same. If I distribute the multiplication over both terms and then do the addition second, I'll get the same result as if I did the addition first, then the multiplication. And that will work every single time as long as I make sure that I multiply what's out here times both of the terms that are there. Well, that fact, and it's what's called the distributive property, that multiplication distributes over addition, and it also distributes over subtraction. It only distributes over addition and subtraction. Multiplication does not distribute over multiplication and division. Because of that distributive property, I can now use that technique to remove the parentheses that are here in this expression. I'm going to distribute the multiplication times both of those terms. I'm going to take the 4 and multiply it times the 2x. Well, that would give 8x. And then I'm going to take the 4 and multiply it times the plus 3, which would give me plus 12. Remember, we always have to have a sign between the terms in the expression. So I almost kind of view this as being a positive 3 multiplied times the 4, which gives me a positive 12 as the answer, which means I use plus 12 when I join that term to the preceding term. So I distributed the multiplication, which enabled me to remove the parentheses. Let's take a look at another example. Let's suppose we had this set of parentheses. And we wanted to remove those parentheses from this expression. We can do that if we will distribute the multiplication times both of the terms that are there in the parentheses. 3 times 3x will give us 9x. 3 times a minus 9 is minus 27. And we have used the distributive property of multiplication over addition and multiplication over subtraction to be able to remove the parentheses that are in that expression. And that's very important because as we go further in algebra, we're going to encounter expressions that have parentheses, and we're going to need to be able to remove the parentheses so that we can go on to other steps in the particular problem we're solving.